Hello, my name is Alejandro,
My name is
and
Alan.
today we're working on our second project for vibrations class, but first we'd like to credit Dr. Yao and UIC for the slides as we're using their formatting.
For this project, we were asked to set up a non-rigid body structure and explain the vibrations, the experimental versus the theoretical data, the error, and what we learned. But first, it's important to mention that we originally were working with a paint-stirred stick, but we decided to change it to a plastic ruler instead because of the stiffness.
And this makes sense because the free body diagram, inertia diagram, vibration model, structure model are all going to be pretty similar, except for the fact that the stiffness is different. So when we're recording, it actually gives us the movement and tracker. This is what it looks like whenever we have it set up where the finger is enacting the force before it actually freely vibrates. We have the books clamping down on it, and we have a wooden block just to ensure consistency of letting it go at the same spot. Now, whenever we let go, and get the data, it looks something like this from Tracker, where we upload it to the spreadsheet given to us by Dr. Yao. And this is exactly what we expect. Higher peaks at the beginning, smaller peaks closer to the end, where eventually it starts oscillating near zero, which you can see there.
From our measurements, we searched up on Google and we found that a plastic ruler is made of polycarbonate. So from there, we use the values of polycarbonate, like for Young's models and on other constants. On the left, we can see the theoretical calculations, and on the right, we can see the experimental calculations. In this case, we want to talk about KE and damping ratio because both cases, these were smaller. And in the experimental side, this makes sense because this is like, and things like in real life, air friction and movement of the ruler could affect like our calculations.
And I'm glad that he mentioned that because before we talk about what we learned, we need to talk about the errors and the limitations of this, where whenever we're talking about a ruler clamped by books, it's probably moving a little bit. We can't see it in the video, which is why we found it acceptable, but using a clamp is a way better way to ensure that it's not moving, but also other things, like you said, like air resistance or just the angle of recording can cause, issues. Because whenever we were getting tracker data, every once in a while it told us like, hey, I can't really see where the red is at. Can you click where it is? So manually, we might have some humor error introduced.
We also learn how to simplify a distributed beam into a single degree of freedom, as well as how to track, how to use tracker how to use our data from tracker to create like a plot, like the one we showed before.
Thank you.
Thank you.